Okay, so in section 7.5, we are going to look at general solutions to differential equations. So we see here in example 1, we're asked to solve this differential equation. This is one of those super simple examples that we have done before. So what you would do is you would multiply both sides by dx. And so when you do that, you've got dy equals 2x plus 5 times dx. So now, we didn't ever say this before, but what we did there is we separated the variables because everything with a y is on the left side and everything with an x is on the right side. And so once we separate those variables, then we can integrate both sides. So y equals, we're just going to integrate here, so that'll be x squared. 2 divided by 2 is 1, so we don't have to write that 1 out front. And they'll have plus 5x plus c. So this is our solution to our differential equation. And we have solved it by separation of variables. So this is a very simple example. Let's look now at some of the more complicated examples that we have not seen before. So here is example 2. This time it says y prime equals 2x over y. Now, I prefer the notation dy over dx for this equals 2x over y. The dy over dx notation is better to use here because what we need to do is we need to separate the x's and the y's in this equation so that we could integrate both sides. So, excuse me. So this one is very simple to separate because we could just cross multiply in this case. And so if we just cross multiply, I'm going to leave the y's over here. I'll have y times dy equals 2x times dx. And so now everything with a y is on the left side. Everything with an x is on the right side. Notice the dy and the dx need to be in the numerator. That's really important. If they're in the denominator, then you can't solve the differential equation. So what we'll do here is we will integrate both sides of this equation. So when we integrate y, we would raise our exponent 1, y squared. We divide out front by the coefficient. So we'd have 1 by the exponent, which would give us 1/2. And then we put plus c. And I'm going to put a little 1 behind it because that c right there, we're also going to have another c on the other side. And then so I've got 2x, and so if I integrate that, I've got x squared. I divide out front by 2. 2 divided by 2 is 1, so I don't have to put that there. And I put a plus c here. I'm going to call it C2 for right now. So these plus c's right here that we have, they are both unknown values. Now, if I wanted to, I could subtract that C1 from both sides. And if I do that, I would have 1/2 y squared equals, and so equal x squared. And then we'd have this plus C2 minus C1. Both of these are unknown values. And since they're unknown values, we really could just combine them and make them one single unknown value. So we could say, we could let C equal C2. Minus C1. So really, what we would have here is 1/2 y squared equals x squared plus c. And that whole business with the C1 and C2, I just did here to show you that those c's could be put together. On every problem we do from here on out, we're just automatically going to put those c's together whenever we solve the differential equation. Now, your answer might look like this. What I think you'll probably see instead is I think you'll probably multiply everything by 2. what that does is that gets rid of that 1/2 right there. And so we'll have y squared equals 2x squared. And then we've got a c here. We'll have 2c, but 2 times an unknown number is still an unknown number. So I'm just going to leave this c. I'm not going to change anything about it. And so you might see the answer written like this. You also might see that 2x squared moved over to the other side. Just depends on what the answer choices look like for this problem. So we'll just leave it here for what we've got right now. Check the answer choices in the back of your book, and try to get your answer to match whatever they have given you for that answer key. All right, let's move on to this next example. And for this example, it says, which of the 3 differential equations is separable? Not all differential equations are separable. Some of them are not. And we, in Calc 1, only have to solve separable differential equations. When you go to college, if you major in math or engineering, there is a whole separate class called differential equations where you will go into extensive ways to solve many different types of differential equations. But for what we have to cover here, we only have to be able to cover separable differential equations. So if we look at the problems that we have right here, the first one here, I've got y plus t. So if I were trying to separate this, I could multiply both sides by dt. That's pretty much the first step you always want to do, because you have to have your dy on one side and your dt on the other. It might be a dx. It just depends. So dy would equal y plus t dt. You got to make sure you've got those parentheses there. Now, if we try to separate this, we're not going to have a lot of luck, because I can't just subtract that y over to the other side. What I would have to do is I would have to distribute, so I'd have y dt plus t dt, and so I could try to move this y back over to the other side, but if I do, it's got that dt connected to it that goes with it. I could divide everything by y, but if I divide by y, then I'd also have to divide t over dt by y. So this particular differential equation is not separable. So this is no for that one. That one is not separable. And typically when you see things like y plus t or x plus y, those are not going to be separable in most cases. So let's look at the next one. For this problem, I've got dy over dt equals ty over t plus 1. So the first thing you pretty much always want to do, multiply both sides by dt. That gets your dy and your dt separated. So you've got ty over t plus 1 times dt. And this time, you've got this y right here that you need to get rid of. And you can get rid of this fairly easily by dividing both sides by y. So if you divide by y, you would divide by y here, so it would go in the denominator, and it would cancel, right? And then it would also be a y over here. And we're not going to solve that differential equation, but we've got dy over y equals t over t plus 1 dt. And so everything with the t is over there on the right side with your dt, and everything on the left side has a y, so that has separated the two variables there. C is kind of a little bit of a strange example. I think I wrote this one down wrong whenever I first did this. This one is not going to be separable, and the main reason it's not separable is because if you look at your variables, you've got a y and a t, but over here you've got an x and a y. So if you try to separate your variables, you're going to have an x that doesn't go with either the dy or the dt, which means that these will not separate here. So this one would be, let's see, B would be a yes, C is going to be a no, as it is written. However, I think I may have written that one wrong, and if I wrote it wrong, if it were dy over dx equals e to the x plus y, then this one's a little bit strange because it will actually separate. Watch this. If I multiply both sides by dx, I've got the dx over here. Now this looks a lot like a, where I've got an x plus y, which will not separate, except whenever I'm dealing with exponents, if I have something like x squared times x to the third, then that would be x to the 2 plus 3 power, or the x to the 5th power. So whenever I have e to the x plus y, I could change this and write it this way. I could write it as e to the x times e to the y dx. And so if I write it this way, now I could divide both sides by e to the y. And that would give me dy over e to the y equals e to the x times dx. And now this would be separated, and you could solve that equation. So as it is originally written, this c is a no, but if that t were just turned to an x, then that would be a separable differential equation. Okay, so everything that you're asked to solve will be a separable differential equation. However, you might be asked questions about differential equations that are not separable. You won't be asked to solve the differential equation, but you'll be asked maybe to find a tangent line, or to draw a slope field, or to do different things like that. So you will see a little bit of the non-separable ones as well. You just won't be asked to solve them. Okay. Let's look at this next problem. We've got dy over dt equals y squared e to the negative t. So I'm going to start by multiplying both sides by dt. And so the dt's cancel over here. So I've got dy equals y squared e to the negative t dt. I want the y's to go over to the left-hand side, so I'm going to divide both sides by that y squared that we see there. And so we're going to have, I could leave this dy over y squared, but instead I'm going to do y to the negative 2 dy. I'm going to use those negative exponents to make that side a little bit easier to integrate. And over here on the right-hand side, I'm going to have e to the negative t dt. Okay, so the time has came that we need to integrate both sides of this equation now that we have these separated. And so on this left-hand side, this is a pretty simple one to integrate here. Even though I do have some negative exponents, I'm just going to increase my exponent by 1, which will give me negative 1. And I'm going to divide out front by negative 1. So I'll have negative y to the negative 1. And I could put a plus c, but I'm just going to wait and combine it with the plus c over here on this side. Make sure you don't forget that plus c, because it is incredibly important when we start finding specific solutions. If you don't have that, you won't be able to do the problem at all. Now, for the right-hand side, this is just slightly more complicated than the left-hand side. We do have a teeny tiny u/du substitution here. Our u here would be negative t, which means the du would be negative 1 dt. So with that dt, we need that negative, which means we would have to add the negative out front. And so when we integrate this, we've got that negative that would be out front. The the integral of e to the u is e to the u. So we'd get e to the u, which is just negative t, but we would have that negative out front there. And then I'm going to move this c over a little bit. This plus c would be right here. Now, this really would be negative 1 over y equals negative 1 over e to the t plus c. It's a little hard to tell how they'll actually leave the answer on that. Check the back of the book and try to get your solution to match. I'm just going to leave this one like this right now. Okay, and here's our last one. This one is by far our most complicated one that we'll see today. And so, again, remember I said that y prime, we really don't want to use the y prime. We want to think of this as 1 plus x squared dy over dx plus 3xy equals 0. So the first thing I would always do is solve for that dy dx. So we've got 1 plus x squared dy over dx is going to equal negative 3xy. And then I'm going to go ahead and divide by this 1 plus x squared here. And so when we do that, we get dy over dx equals negative 3xy over 1 plus x squared. And so at this point, we want to multiply both sides by that dx. So we can move it over to the other side. And this is going to give us dy equals negative 3xy over 1 plus x squared dx. And so on that right-hand side, all you have is this single y right here that needs to be moved over to the left-hand side. Negative 3x and y are all multiplied together. So it's perfectly fine here just to divide both sides by y, which is going to cancel the y on the right-hand side, and you're going to divide the left-hand side by y as well. So that gives you dy over y equals negative 3x over 1 plus x squared dx. And we are going to integrate both sides. Now, whenever I look at the left-hand side, it's very simple. We may have forgotten this rule, but whenever we integrate dy over y, or we could think of that as 1 over y times the dy. When we integrate 1 over y times the dy, we're going to get natural log of y. But I'm going to hold off on integrating this because I need to do a u/du substitution on the right-hand side. And I want to integrate both sides at the same time because when I put that plus c, it has to go for both sides. So I am going to go ahead and do my u/du substitution first over here on this right side. So u on this right-hand side is going to be 1 plus x squared. And that means that du is going to be 2x dx. Well, here I have this negative 3 right here that's kind of in the way. So I'm just going to pull that negative 3 out front. And I'm going to add the 2 that I need right there. But if I add the 2, then that means I have to multiply out front by 1/2. So this is going to look like this. I'm going to have dy over y equals, and then I'm going to have the negative 3 that I have pulled out front. I'm going to have multiply that by the 1/2, which is going to give me negative 3 over 2. The integral of 1 over u du. And so at this point, I'm going to integrate both sides. So I'm going to have the natural log of y equals negative 3/2 times the natural log of u plus c. And the u is actually 1 plus x squared. So that means I've got natural log of y equals -3/2 times the natural log of, I guess I should have absolute value bars there, absolute value bars of 1 plus x squared plus c, or actually on this one, I don't have to have multiple absolute value bars on this problem because 1 plus x squared is always positive. So if you just have parentheses, that's fine as well. So for right now, we're just going to leave this answer as it is. As we go on, we're going to learn to simplify that a lot more, but we're just going to leave it right here for right now. So those are our examples that we're going to look at. Your assignment that you're going to have is going to come from the textbook. So we will be looking at page 382, numbers 1 through 8. And I will post a picture of numbers 1 through 8 on Canvas. And what I want you guys to do for this particular assignment, since it is a bookwork assignment, I want you guys to work it out on notebook paper and then take a picture of your assignment and email it to me. And that's how I'll give you credit for the assignment. So thank you for listening. If you have any questions, feel free to contact me and I will try my best to help. Thank you.